Okay, guys, we're getting there. We're getting to the exam questions now. And before we get there, I just wanna show you this table before we get into the to those parts. So there's this table that shows us how the information about the nature of roots of an equation can be translated, right? So I'm just gonna draw a simple table. Okay, I can just draw a simple table like this now. Okay, and then I'll just do something like that. So basically, is that here you have your nature of roots, right? Nature of roots, and then this is just the value of the, let me just say value of delta, ne? Because I don't have a lot of space, I'll just say value of delta. So if we have real roots for an equation, we know that if our roots are real, it has to be greater than 0, right? Our discriminant firstly is greater than or equals to 0. We say that it has real roots. 0 is considered to be a real root, because then if we square root if we square 0 is a perfect square, you agree, right? So the square root of 0 is actually 0, right? And then we also have one where we have non-real roots. I don't know how to use this table, but okay, non-real. So we also have non-real roots. So if we have non-real roots, we know that it has to be the opposite of this, right? So non-real, it's basically less than 0, but 0 is not included in this time, because it's, if it's non-real, it would be any value that's just below 0, any value that's just below 0. And then if we have a solution where we have like one solution, so let's say equal roots only have one solution. So let's say for equal oh, excuse me for my handwriting, equal roots, we say that delta is equals to 0, right? So let me show you a typical example of equal roots. So a typical example of equal roots would be like if you had an equation where you had x squared, right, plus 2x plus 1, then you have equals to 0. Then you open two brackets, so the basically the roots here are just x plus 1, and then you have x plus 1 equals to 0, and then they are just both the same at this point. X plus 1 times x plus 1, so you just say that therefore x will be just be equals to -1, and this equal roots only have one solution, and the solution here is just x is equals to -1, right? So that's an example of having one solution, right? Yes. And then from there we also have unequal real roots. So let me just draw another example of unequal real roots. So when we have an unequal real root, so for unequal real roots, I think we have done an example, guys. Remember that example that we did where we had x squared plus 5x plus 6, right, which was equals to 0. Then we say that we had x plus 3, and then we had x plus 2, and they're unequal because then we have two different solutions, unlike the one previously where we had only had x equals to -1. But here we have x is either equals to -3, or where x is equals to -2, and we have two unequal real solutions where we have two possible solutions. And then, like I said, if we have a situation where we have a perfect square, like when we did previously, we found that the square root of 1 was actually 1. And it is a perfect square. And because it is a perfect square, we did say that if it is a perfect square, so we say that our solution was the square root of 1, which was equals to 1, right? And this is said to be a perfect square. And because it's a perfect square, we also know that it's also rational. It's rational. It can be written as a form as a fraction, as 1 over 1. And if it's rational, it's a perfect square. And if it's irrational, it'll be the opposite of it. So it's not a perfect square. Then if we have irrational roots are not are not perfect squares. They are not perfect squares. They're not perfect squares. So let's say we had something like -7. If we had a discriminant like -7, is -7 considered a perfect square? No. Or let's say even, yeah, -7. It's not considered as a perfect square, right? So that would be an example of -7. Yeah. So Now we're gonna move on to the exam questions, and we're gonna start with a basic example, and then we're gonna dive into the bonus question. There's a bonus question.